Good morning, everyone. Today we are going to be covering angles formed by transversals. So just a few things I want to go over with you in a sort of review before we get started learning the new stuff. So these are going to be some important concepts that we need to remember for today. Supplementary angles are a pair of angles that together form a straight 180-degree angle. And these ones in particular are also referred to as a linear pair when they're both adjacent and supplementary. So they both go together on the straight line. Next, we need to remember our vertical angles. These are two angles that are across from each other at a set of intersecting lines. So where two lines form an X. You'll have this pair of vertical angles and this pair. And the big thing to remember is that these are always congruent. And lastly, the term adjacent angles is two angles that share a side. So this side is both from the vertex out on this angle and on this angle. It's important that that vertex is a part of that line. If you had something like a Z, technically these two angles are sharing a side, but not a vertex. So it may be important to add in that not only do they share a side, but they also share a vertex. All right. So the reason that was so important is when we're looking at angles formed by transversals, we're also looking at angles formed by intersecting lines. And we're going to see that supplementary and complementary angles are so important to these. So I'm just going to flip ahead to my next page. Oops, that's midpoint formula. I didn't add midpoint formula here. Whoa. Wow. You live and learn. All right. So page 13 will be angles formed by transversals. I apologize if that confused anybody. But hopefully not. If you were keeping up with your table of contents, shouldn't have messed you up. I had the mistake because I wasn't keeping up with it. Angles formed by transversals. Hold on. So let's review just a little bit and look at angles formed by intersecting lines. So I just drew a pair of intersecting lines and I labeled each of the angles formed 1, 2, 3, and 4. So the reason I'm bringing this up is I really want us to be good at identifying adjacent angles, supplementary angles, and vertical angles. Because if we don't have a good grasp on that, then when I add in the transversal, which we'll learn about, it'll get really confusing. It'll be a lot to keep track of. So when we look at this picture right here, let's identify some adjacent angles And these are angles, again, that share a side. So 1 and 2 share a side. 2 and 3, 3 and 4, and 1 and 4. So we have a lot here. All right. So in this particular set, there's also the same amount of supplementary angles. A little sheet of paper. So anytime you have two angles forming a straight line, they are a linear pair and they are supplementary. So we can see that all of our adjacent angles in this case also happen to be supplementary as well. Now, of course, that isn't always the case. Not every adjacent angle is also supplementary. But in the case of these, they are because they're forming those straight lines. And then lastly, we have vertical, which I don't have a whole lot of room, so I'm going to write it over here. And in this case, when two lines intersect, we only have two pairs of vertical angles. The ones across from each other, so angle 1 and angle 3, and then 2 and 4. And this is mostly a review. We've already learned all of these terms, but I wanted to go over it with you guys before I add in the new stuff to make sure we're really seeing and understanding what adjacent, supplementary, and vertical angles are. All right, so let's get into what a transversal is. Using my trusty green for definitions, a transversal is a line that intersects two or more lines. So see why intersecting lines were important to review? So let's draw a little picture. Let's say we have this line L and this line M. It isn't very important how L and M look, but they shouldn't be touching each other, at least in this case. And then our transversal, which I will call T appropriately, is one that is intersecting at two different lines. So notice, whoops. Okay. So notice how T is intersecting both L and M. So T is our transversal, but L and M are only intersecting one line. So therefore, they are not called transversals. And I'm just going to use my highlighters to highlight that transversal, which doesn't show up too well. And transversals come in many different shapes and sizes. So T intersects both L and M. So it is a transversal. All right, stay with me, guys. We're going to learn about 4 new angle relationships. So these are the titular thing of today, angles formed by transversals. So I'm just going to take this diagram down here and add a few more things to it. I don't want to add them all to this one because it might get a little bit cluttered for you when you're reviewing your notes. So maybe I'll shorten it just a little bit so we can fit everything a bit better. All right, so we have essentially the same thing going on here. L and M are being intersected by T. And I'm going to label the angles, just like I did in the pair of intersecting lines at the top of the page. I'm going to label 1, 2, 3, 4, but we see another X down here. So we have 5, 6, 7, and 8. And I think I labeled these backwards. Oh, I am on the mistake train today. Oh well, we'll roll with this. We will roll with it. It'll be okay. So we have our first type called corresponding angles. These are described as, yeah, I'll write it in this, angles on the same side in the same position. Now, what on earth could I possibly mean when I say that? Angles on the same side in the same position. Well, if we're looking at our picture, we have this transversal T, and it's kind of splitting this picture into 2 halves. We have all the angles on this side, and we have all the angles on this side. Those are the 2 sides we're talking about on either side of the transversal. Up here, this side, and this side. So in this case, angles on the same side would include 1, 3, 5, and 7, or 2, 4, 6, and 8. So either the odds or the evens. Now, there's also same position. What does that mean? Well, we have kind of a square here. Upper left, upper right, lower left, lower right. Those are the positions. We see the same down here. Upper left, upper right, lower left, and lower right. So when they're on the same side and the same position, then we're talking about upper left and upper left, upper right, lower left, lower right, and lower right. So examples of corresponding angles would be angle 1 and angle 5, angle 2 and angle 6, angle 3, angle 7, angle 4, and angle 8. Again, 1 and 5, 2 and 6, 3 and 7, 4 and 8. There will always be 4 pairs of corresponding angles for each set of lines cut by a transversal. So then we have alternate interior angles. And these are interior angles on opposite sides. Of the transversal. So whenever I talk about a side, I'm talking about a side of the transversal. So notice how it says interior. We already talked about sides, so opposite sides would be one here and one here. But what about interior? Well, if you think about these two lines, we have a region that's in between them, and we have a region that's outside. This region in here is what we call the interior. And we'll also see in a moment that we have an exterior as well. I'm looking for my highlighters. They're all going missing. Oh, there it is. So we have our interior and exterior, but for right now we're looking at interior. So we're talking about 3, 4, 5, and 6, and they're on opposite sides. So 3 and 4 are on opposite sides, and they are on the interior, but this word alternate is very important. So when we're looking at alternate interior angles or exterior, we're thinking about a Z. So we're looking for non-adjacent, and that's an important note. It's not 3 and 4 because those two are adjacent. They're sharing this side. We want ones that are on that Z. So 3 and 6 would be alternate interior angles. And that's not the only pair. We also have 4 and 5. So again, these are non-adjacent, which is why 3 and 4 and 5 and 6 are not alternate interior angles. They're adjacent, but they're not alternate interior. Those would be 3 and 6 or 4 and 5. In a similar vein, we have alternate exterior angles. And if you got alternate interior, these are very similar. So exterior angles on opposite sides. And guess what? That non-adjacent also applies to this guy. So because we're talking about non-adjacent exterior angles, we're working in the green region now, those that are on the outside of the sandwich. I kind of think of it like a sandwich. These are like my bread slices. Those would be my exterior. And then this is my filling, which is on the interior of my sandwich, hopefully. And maybe the transversal is like a toothpick going through it. So looking at angle 1, if we're figuring out which of these is the exterior to it, it wouldn't be 2 because it has to be non-adjacent. It wouldn't be 7 because those are on the same side and we want opposite. So that means 1 and 8 are alternate exterior angles. And 2 is also on our exterior. So again, not 1 because that's adjacent, not 8 because that's on the same side, 2 and 7. All right, and we have one last one for today. These are same side interior angles. These are sometimes known as consecutive interior. But I like same side interior because the name tells you everything you need to know. They're interior angles on the same side. So, final set of examples. Same side interior angles on the same side. We're working in the purple again, that's our interior. And I want ones that are on the same side. So 3 and 5 are on the same side. And 4 and 6 are on the same side. And that's it. We've identified all the different angles formed by transversals. Now notice I have not talked about adjacent, supplementary. Well, I talked about adjacent. I haven't talked about supplementary or vertical here. That's because we need to be identifying these already. So I didn't go over which ones here, are supplementary and which ones are vertical, because we need to be able to look at this picture and always see those. Like going, boom, those 2 are supplementary. Boom, those 2 are supplementary. Boom, those 2. Boom, those 2. And always looking and seeing those, as well as seeing all of our vertical angles across from each other. 1 and 4, 2 and 3, 5 and 8, 6 and 7. But it would be a lot to list out all of those as well. So that's why we did the practice at the top of the page. Now, as for why the heck these things matter, when we get into a very special type of these tomorrow, we're going to need to be really good at identifying these because they have very special properties when the 2 lines, L and M, are parallel. And if we want to use those properties successfully, we need to be able to tell where our corresponding angles are, where our alternate interior and exterior angles are, and where our same side interior angles are. Because if we can't properly identify those, then those properties won't be of any help to us. So for today, we are going to focus on just identifying all of these. And I'm going to post a video if you need some extra help with another example of identifying all of these angles in another pair. And please note that when these are numbered, it's not always going to be angle 1 and 5 that are corresponding. You have to look at how your diagram is labeled. Because I labeled it 1, 2, 3, 4, whoops, 1, 2, 3, 4, but others could label it 1, 2, 3, 4, or even 2, 3, 4, 5. So pay attention to your labels. That is what will determine what your corresponding angles are, not the fact that angle 1 and angle 5 always have to be corresponding. Okay, I think that's all I have for this video. If you're stuck on your work and you need a little extra help, I'm going to upload a video with another example of this. All right, see you next time.